Welcome back, everybody, to another edition of No Here, No Problem. Today, we are going to be working on slides 5 and 6 from Unit 2, Objective 1, where we're talking about how to simplify square roots. Last time we were working together, we all focused on the many different properties that could take place when you're worried about solving these or simplifying these, and we were talking about rules related to exponents. And if you remember, I told you all that there was a much easier way to actually go about these. And we're going to work on using that easier method right here. So in order to do simplifying square roots in the easiest way possible, it requires that you actually take some time to fill in this table. What we're looking at here are things called perfect squares. Perfect squares are numbers that when you multiply them by themselves, we get this number. And there's a little family that's going to take place with this. And we're going to practice this family in class, okay? So if I was to take 2 to the second power, let's start here. 2 to the second power is going to equal 4. So then if I was to go backwards and say square root of 4, you would say it's equal to 2. Okay? If you remember when you were a kid and you first learned how to do like adding, subtracting, multiplying, dividing, there were like these families that you would learn. So like, for example, if I said 10, 2, and 5, you would say 10 divided by 2 equals 5. 10 divided by 5 equals 2. 2 times 5 is equal to 10. 5 times 2 is equal to 10. So there are 4 connections that you can make with those 4 numbers when you're doing that. I'm sorry, with those 3 numbers. And that's what we're going to do with these, is we're going to have these families that we're going to practice going through and reciting them over and over and over and over, because we need to become very proficient at these. So if we look at the second one here, we've got 3 to the second power, which is going to equal 9. So the square root of 9 is going to equal 3. Because 3 times 3 equals 9. The next one we're going to do is 4 to the second power, which is 16. So the square root of 16 is going to equal 4. Okay, they go both directions. The next one, we're going to go 5 to the second power, which is going to equal 25 because it's 5 times 5. And so then the square root of 25 is going to equal 5. Okay. If we go on to the next one here, we got 6 to the second. That's like saying 6 times 6, which is 36. So the square root of 36 is going to equal 6. Okay. The next one here, we've got 7 to the second power, which is just going to equal 7 times 7, or 49. So the square root of 49 is going to equal 7. Okay. The next one is 8 to the second power, which is going to equal 64. So the square root of 64 is going to simply equal 8. All right. The next one here we're going to have is 9 to the second power, which is 81. So the square root of 81 is going to equal 9. The next one is 10 to the second power, which is saying 10 times 10. So that's 100. Square root of 100 is going to equal 10. Let's see. The next one is 11 to the second power. So that's saying 11 times 11, which is 121. Square root of 121 is simply going to equal 11. The next one is 12 to the second, which is 144. Square root of 144 is going to equal 12. A couple more here, you guys. The next one is 13 to the second, so that's 169. Square root of 169 is equal to 13. The next one from there is 14 squared, which is going to equal 196. So the square root of 196 is equal to 14. 15 to the second power is 15 times 15, which is 225. Square root of 225 is equal to 15. 16 to the second power is 256. And then 256 square root of 256 is going to equal 16. I don't know if we have to do square root of 17. 17 squared. Let's see. 17 squared. I'm trying. I think it's 289, but I'm going to confirm it. I'm doing this all mentally, and I am exhausted right now, you guys. Let's see. So that's 49. That's going to be 7 and 4, which is 11, 0, 7, 1. So yeah, 289. Having a brain fart here, everybody. All right, so then we get 289, which means the square root of 289 is simply going to equal 17. Generally speaking, we don't have to go up to these high of numbers, but it doesn't hurt to have these, okay? So just go ahead and pause, go back and write the values down. Make sure that everybody's got these down because you're going to be using these pretty frequently. All right, so let's move on to actually simplifying these problems in the fastest and easiest way possible. Using the chart over on the left side there, let's figure out, and maybe we should pause this here. This would be a good time to pause. Let's go ahead and find these values over on the chart there, and let's simplify them. So for the first one, square root of 36, pause it. Let's go through and do these. All right, let's come back. Square root of 36 is simply going to equal 6. And these are straight over on the chart there. Square root of 49 is going to equal 7. Square root of 121 is going to equal 11. Now let's get into problems where you're going to have a little more details. When we look at what's happening on number 3 here, what this says is 3 times the square root of 25. Well, that square root of 25 from my chart is equal to a 5. So that 3 times 5 means that we simply are going to have 15. If we go to the next one here, we have a square root of 16. So we have negative 2 times 16, which is square root of 16, which is 4. So this means that our answer is going to be simply negative 8. The next one we're going to have is negative 9 times the square root of 10. I'm sorry, square root of 100, which is going to equal 10. So we end up with a negative 90 for the overall value on that one. So these are pretty straightforward. And this is not the only mode that we're going to actually see these. We're going to see these in a lot of different settings. So for example, we can see these in fractions. We can see these in multiplication. We can see it in adding and subtracting. We can see it everywhere. But we have to make sure that radicals are always in their simplest form. So when we look at fractions, such as square root of 16 over the square root of 25, what we should understand is that we can actually take these square roots and break them into the numerator and denominator. So when we have the square root of 16 and square root of 25, we break it into the numerator being square root of 16, which is simply going to equal the square root of 4. And then for the denominator, we do square root of 25, which is simply going to equal the square root of 25, or just 5. And so our answer for this would just be 4 over 5. When we look at another one like this, where we've got 8 over 36, the 8 is just an 8. It's not in a square root, so we don't have to do anything to it. So it stays exactly as it is. That 8 doesn't change. When we look at the square root of 36, though, that square root of 36 does change. That square root of 36 we can simplify, and that's going to equal a 6. And then we just take our fractions and reduce them. So let's look at a couple of examples where we can actually simplify these. First, let's look at this fraction. We see that the square root around this is around the entire problem. That means that the square root is being applied to everything that we see inside of this. So let's break it up into 2 separate parts. We've got first that square root of 100 on the top, which you can use your chart on the left side there, you'll see is equal to 10. And then for the bottom here, we've got the square root of 49, which has taken place, and that simply is going to equal 7. And we look at this and we see that the 10 and the 7, if we try to reduce them as a fraction, that won't reduce. So our final answer for this is going to be 10 over 7. Take a look at the next one here. Again, anytime you want, pause it, try to do the problems. Please have your teacher, Ms. Z, or whoever is doing it with you guys, go ahead and pause it. Try these problems on your own. All right. But let's take a look at this next one here. So this 10, it's not in the square root. Therefore, it's not going to change. We just leave it as it is. On the bottom, though, we have the square root of 64. So let's go ahead and write that out here as the square root of 64. So we end up with 10 for the numerator and a square root of 64 on the bottom, which is going to equal 8. I guess I didn't have to rewrite that whole thing to be 10 over square root of 64, seeing as we already had that over here. These are the same. Sorry. All right, so if we go from there and we simplify this, put 10 over 8 into our calculators or just mentally reduce them, I can divide both of these by 2, and we end up with a 5 over 4 for the overall answer here. No decimals, please. Okay. So what about when we're trying to combine like terms in terms of radicals, and how do we add and subtract these together? Well, it actually is no different than when we talked about combining like terms the old way, where there's just an x and a y involved. When we look at the values that are similar, we see that there's a 12x right here, and we look at all the other ones and we see that there's also a 7x right here. If we just put those two together, 12x plus 7x equals 19 total x. That's just putting those two parts together. When we go ahead and we put the other portions together, the 3y and the negative 10y, because those are the same, they both have y's involved, we can put them together. We have 3y's and we have minus 10y's, which is going to equal negative 7y's. What I want you to really pay attention to is the fact that my x's did not change, my y's did not change, just the coefficients, the values in the front did change. Let's apply this to these problems over here. Take a look at number 5. We have 8 square root of 5's, and then we have 6 more square root of 5's. As long as these values, the radicals, are the same, we can put these roots together. So if I was to say 8 square root of 5's plus 6 square root of 5's, well, what's going to happen is the square root of 5 is not going to change. Just like up above, my x's and y's did not change. So this means that we're going to have 14 square root of 5's. I've got 8 square root of 5's. I give you 6 more root 5's. I've got a total of 14 root 5's going on in this problem. Okay. Let's continue on here. Find the ones that are similar. Let's put these together. So we've got 8 root 3's minus 2 root 3's. We've got 3 root 7's and another root 7. So what we're doing is we're looking at the things that have the same roots and we're putting those together. So I have 8 root 3's and I take away 2 of those root 3's. We still end up with 6 root 3's. Okay. If I look at the 3 root 7's and I add a root 7 to it, so really I'm adding 1 root 7 to it because there is 1. We don't have to write the 1, but there is 1 of those. That means that we're going to have 4 root 7's. And so the answer for this would be 6 root 3's plus 4 root 7's. Just combining like terms. That's all we're doing there. All right. Let's move on to actually going into the harder problems, which is simplifying by using perfect squares. So last time when we did these, what we did was we went ahead and we did the prime factorization for this. And you could still do prime factorization, but I'm showing you a method that's going to be even faster than this. Okay. What we're going to do is I'm going to do it both ways. So you can see what it looks like both ways. Here's the prime factorization tree when we're going through and doing this. This is going to equal 2 and 30, 2 and 15, 3 and 5. And if you recall, what we said was that when we have the whole thing factored out into its prime factorization, we said that those square roots are going to go ahead and anytime we have a pair, it's a couple, they go out together. And anything that's not a pair, those odd men on their own, those 3 and the 5 are going to stick together on the inside. And so we're going to end up with 2 and then 3 times 5, which is 15. So this is using the prime factorization method. Now let's use perfect squares. What do we mean by that? Well, look at the values here. We get 4, 9, 16, 25, 36, and 49. And what we're going to try to do is we're going to try to see if any of these factors are in fact perfect squares that are factors of 60. Now this is slow at the first time. It takes a minute. You'll get used to this. But what we're going to do is we're going to break this into 2 separate values here. Okay? 2 numbers that when we multiply them together are going to equal 60. Okay? So start by the bottom here. Can I take 60 and divide it by 49? No. Can I take 60 and divide it by 36? No. Can I take 60 and divide by 25? No. Can I take 60 and divide by 16? No. Can I take 60 and divide by 9? No. But I can divide it by 4. So let's put the perfect square here in that first spot, and then the other value inside of there. So what is 60 divided by 4? 60 divided by 4 is going to equal 15. Okay? So now when we look at this, what's the square root of 4? It's 2, and the square root of 15 stays the square root of 15. And that's it. This is our final answer. Now, as I said, this was slower than doing the other one. You can still do the other one if you want. I really don't care. But just learn that this other method we just did is actually faster with practice. So let's take a look at the next one here, for example. Okay? 40. We are looking to see, are any of these values that we see here, 36, 25, 16, 9, and 4, are any of those factors of 40? Some of you are going to jump out right away and you're going to say, it's 4 again, just like the last one. If I break this up into 4, 40 divided by 4 is 10. The square root of 4 is 2, so we get 2 square root of 10. Boom, you're done. If I still wanted to use the prime factorization, we would have 2 and 20, 2 and 10, 2 and 5. We would go ahead and set up our couples. We'll go out once. Singles will stay inside. And we end up with 2 root 10. So quite frankly, for me, the method that I would choose is this guy right here because it's a little bit faster. And again, you get the hang of it. All right. So what I would suggest is pause the video. Just pause it. Try to do some of these problems. See if you can simplify them. Okay. All right. Welcome back. Let's go through a couple of these and try to simplify them. Okay. So we're looking for, starting from the bottom here, we're looking for is 49 a factor of 98? The answer for that is actually yes. It's 49. 98 divided by 49 is equal to 2. So now the square root of 49 is just going to be 7. So it's 7 root 2. All right, that's it. You're done. You're done. There's nothing else you can do. This root 2 right here is a prime number. It has, I'm sorry, it's not prime. Well, it is prime, but it has nothing else that's a perfect square. That's a factor of it. So you're done. Let's take a look at number 3. That 3, we're just going to carry it with us for the time being. It's not going to do anything until we're ready to work with it. So now let's start with down here and work our way back up to the top. Let's see if these values are factors. Look at the square root of 500. It is divisible by 100. 500 divided by 100 is equal to 5. So continue on with this. We have a 3. Square root of 100 is just 10. And then we have 5. So put these together. We have 30 square root of 5 for our final answer. One of the nice things, I didn't mention this before, is that you can always actually check these on the calculator to make sure that you have these right. If you put both of these in the calculator, you'll see that they'll actually yield the exact same answer. Okay? Take a look at number 11. We've got 4, 9, 16, 25, 36, and 49. We're looking to see which one of these, if any, are perfect squares that work with the 32. I cannot take 32 and divide it by 49. I cannot divide it by 36. I cannot divide it by 25. But I can divide this by 16. And what we end up with is 16 and 2. So we end up with 4 root 2. So this will be 28 root 2. Now I want to point out something. This is where a ton of mistakes take place. I said to you when you're finding the factors, you start at the bottom and you work your way back up to the top. You start from the highest values and you work your way back towards the lower values. So there's some people that just don't listen. Okay, some people just have to learn the hard way. And what you'll see people do is they actually start here and they work their way back the other direction. Because what people do is they stick to things that are comfortable for them. 16 is a big number to take and divide 32 by. But you know it's not a big number to divide by? 4. And what people do is they say, well, that 32, I can actually go ahead and say is going to equal 7. And I can break this up into 4 and 8. And if I do that, we end up with 7 times 2, which is going to equal 14 root 8. And then everybody thinks they're done. Well, the problem is that this 8 that we see right here, I can go even further with it. I could divide that by 4. If I divide that by 4, this is going to end up being a 4 and a 2. So we have 14 times 2 times root 2, which will be 28 root 2. So you'll notice here, when you look at these, both methods yielded the exact same answer, 28 root 2. But look at the first one. By me starting with the biggest possible perfect square, not the 4, but the biggest one, I got to the answer faster. Versus in the second one, where I went ahead and just used a factor that I knew, which was 4, I got there. It just meant that I had more work to do to get there. Okay? All right, why can't the square root of 15 be simplified? Talk amongst yourselves, figure it out, and then let's come back together. Okay, the reason it can't be simplified is it's got no perfect squares for factors. The only factors for 15 are 1 and 15, 3 and 5. None of these values are perfect squares. So root 15 has no perfect squares. That's it. So for today, you guys went ahead and you did the, let's go ahead and fill this in here. Okay, so the activity in class here for today is that you did slides 5 and 6. Okay, and now for homework, if you guys take a look at what you're going to do, you're going to do slides 7 and 8. Slide 7 and 8. Slide 7 and 8. I will have the key on here so that Miss Z can actually check the answers. But that is it. You guys behave. Please take care. Do the work. Don't give me problems to the sub. And we'll touch base again on Friday. And we'll make sure that you guys know everything that's going on, okay? Take care.